Hello, everybody, and welcome to this second offering for the academic year 23-24 of our webinars. We will give a couple of minutes for other colleagues to join. We are very excited today to host Dr. Sang-Ri Yi and Binyan Zhou. I hope I'm pronouncing your names correctly, from the SimCenter. The SimCenter is an AI center for digital technology and computational frameworks in the area of natural hazards. And the Sang-Ri and Jin-Hyun will tell us more about how the center has developed and what are the particular tools and projects that they are working on to both in the area of hazard descriptions, asset event representation, but also at the individual assets and at the regional scale assessment. So couple of more minutes. Sorry, there is a problem with the projection.
Dina, that was the last slide, I think.
Yes, there is a problem with the projector. It doesn't progress. So.
No, I think that was the last slide.
But I ask you to start from the start. Let's see if it works this time around. Can you see my screen?
Yeah, but I need to switch
it.
it.
Usual, I need to swap. Thank you very much.
Yeah, it's working fine now, Dina.
Yes, thank you. Thank you, everybody. So I think we will start. So this is just a recap of what we have delivered so far. Now from the beginning of our working with within the UNESCO chairs. And of course, we thank all our partners and our speakers during the last 18 months for delivering interesting seminars and webinars to all our audience. Recently, we have sent around a survey to all of you, asking whether in particular you would be interested in a number of courses these are the 2-day training courses that we had delivered in last years. And we were keen to deliver again if you are interested. And the answers very kindly has been that yes, there is interest, and there is quite some interest in the glossy course, but also in the system resilience and the application of the Bayesian network for decision making in civil engineering problems, and the engineering-based fragility and vulnerability assessments. We see less interest in the structural resilience of reinforced concrete and masonry buildings, which is of some interest in its own right, because we thought that strengthening solution would be a particular relevant point for our audience of engineers, but maybe we will wait for a few more answers to our surveys, and we will certainly put together a schedule for a second delivery of these courses in 2024. I'm also very excited to say to all of you a big thank you in following us. We now have more than 1,600 followers within for the UNESCO chairs, and as you can see here, from more than 80 countries worldwide. So I'm very pleased that this audience is global, and I know that not everybody can attend all the seminars and webinars at all time, given the level of the time lags and that there are between different parts of the world. But it's also very reassuring that many of these events are then followed on our YouTube channels. So for the next few weeks or months, we are looking today at the introductions for all of our audience to the SimCenter and their computational framework. When we will then have a pause for Christmas, and we will come back first with a webinar delivered by a company called Thornton Tomasetti, which is a global engineering and architectural company, which will talk about this is their office based in San Francisco, and they are looking at how do you go from post-earthquake forensics to actually start designing in terms of recovery-based design. So moving from performance design to recovery-based in order to minimize the costs of recovery. In terms also of the sustainability frameworks. And then in February, we are very happy to have partnered with the ERI Confined Masonry Networks, and we will deliver a 2-day workshop on recent advancement and the way forward in confined masonry construction practice. Here, the idea is to look at countries where there have been standards on confined masonry and moving on to how we can extend this to other countries where there is interest in confined masonry in seismic environments, but they are not yet being an uptake as it should, and how we can promote policies and delivering standards in that directions. So there will be about 12 talks over the 2 days, and registration opens in January. And if you want to attend, or if you want to also contribute in any way, please contact us at the usual address and get in touch as soon as you wish or can. We will soon produce the program on our website as usual. We will have, as we mentioned last week, but for last month indeed, but for colleagues that were not there. So we are moving from Eventbrite to Zoom webinar. So you will receive our invitations directly through Zoom. You can register there and you will directly receive the link rather than having to go through Eventbrite. And with this, and without further ado, I thanks once more Sang-Ri Yi and Jinian Zhao for agreeing to deliver this seminar on computational framework to simulate impacts of natural hazard, the SimCenter, the NRE Center for Computational Modeling and Simulation. Thank you very much, Sang-Ri and Jin Hao. The screen is yours.
Thank you so much, Lina. Hello, everyone. Thank you for joining. I'm Sang-Ri Yi, postdoctoral researcher at UC Berkeley, but also I'm a software developer at SimCenter. So in today's presentation, I would like to start by introducing what is SimCenter and how we help you to simulate natural hazard risk modeling and analysis. And then we go into more focused topic of surrogate modeling for seismic risk assessment. And if the time allows, I will also show you some live demo. And in the second part of this presentation, Dr. Jinyan Zhao will present our regional simulation tool called R2D, which is really about assessing resilience in the regional scale. So SimCenter is a 9-year research project funded by NSF in US. So we are actually part of a bigger, large-scale collaboration with different facilities involved. But in this consortium, we are having kind of a unique position because, as you can see, most of those are experimental facilities and we are only one simulation center. So we sometimes position ourselves as a virtual experimental facility because we really have them to run experiments in computer experiments to investigate like different possibilities. So our SimCenter have several objectives. First one is advance of technology. So we want to advance the capability to simulate the impact of natural hazard on structures. And for this, we have lots of faculty domain experts involved across the US, and they are really the leading experts in the domain. So we have created several task force groups, working groups, and also we meet regularly to identify the state of art of current status and also to identify the gap. And then the unique thing about SimCenter is that we provide the software platform. We actually develop software tools that can be used as collaborative research platform. And this is actually used to develop the functionalities internally inside SimCenter, but also we share this directly through our tools so that user can easily incorporate them. And furthermore, user can share their methods through our software platform, and then other user can take it to combine them with their own innovations. And then finally, we focus on educational outreach by supporting researchers and practitioners with education and trainings. So this will provide, this is really to provide playground for the researchers who use our tools, and also to lower the barrier for the new researchers. And also we try to help them have a larger impact to the community through these activities. So this is SimCenter team. As I showed, we have many faculty domain experts involved from different universities. And these are the people who actually develop the softwares. So this development team is led by Dr. Frank McKenna, who is architect and chief developer of SimCenter, as well as OpenSys. So he created the SimCenter workflow, and also he's leading our development team. And for us, most of us are actually postdoc, and some of us are even faculty. So we really have, each of us have one domain expertise in one domain, and we really try to reduce the gap between what community needs and what we can provide. And then only for those who are near graduation or looking for postdoc position, I want to inform that we are hiring new postdoc at the current moment. So what we developed is a unifying simulation platform that more or less look like this. And our target users are researchers, industry, and government agencies. And we developed not only one software, but multiple ones with different levels. I will go into details in a moment. And then one unique thing is that we also link our user interface with some cloud supercomputing resources. So you can really click different button and then the program will run the analysis in the cloud computer rather than in the local computer. So this application is really to foster large-scale collaboration in the disaster science community, but also it will help you to extend the impact of your research contributions. So if you can plug in your analysis in our workflow, then it will show how it will affect the downstream analysis, like the quantities which the society really cares about. So and to achieve that, our workflow follows that of performance-based engineering workflow. So here the core idea is that each pieces are first decoupled and then reassembled in a very modular way. So for that reason, we like to illustrate our workflow as a jigsaw puzzle pieces that start from describing asset and hazard and goes all the way to simulating the recovery. So what we are trying to do in the center is to encapsulate those modular pieces and then connect them in a seamless way to make the collaboration between different fields easier. This is example of what kind of things we can do through our tools. For example, this is an example workflow for regional seismic analysis you can run through R2D. If you see that for each pieces we support different choices, more than one choices, so you can really combine those to create your own workflow. So for example, you can create workflow that looks like this, and then you can also easily switch from one to another to compare their influence to the final outcome, and also plug in your own model, which can to compare with what is already existing in the field. So based on that principle, we have 6 different desktop applications, and each of them serves different user categories. The first one is, and all of them shares the same like basic workflow, but all of them can have subset of those workflow. So the first basic level one is COFEM. It's a general purpose UQN optimization tool, and as you can see, we have minimum like pieces assembled to support this tool. So here user provides some simulation model, and we really enables uncertainty quantification or optimization using the user provided models. And then there is second level applications. Those are hazard specific ones. So hazard specific means we support hazard modeling module, and also additionally we have structural modeling module. So theoretically, or it is really possible to run the analysis without having hazard model or structural model, because we provide some of basic functionalities, but also you can bring your own model and try to connect with other modules that we support. So these tools are used to estimate the structural response given different hazard scenarios. And then the third level tool is called performance-based engineering. So it takes the high resolution response from these other tools and also connects the damage and loss assessment module so that we can really estimate the performance. But until this, we care about individual buildings, and for the finer with the finer tool called R2D tool, we really scale up this analysis to the regional scale analysis. And I would like to briefly go through one tool by one tool. for the next few slides. So first, I would like to start with the QuaFM tool. So QuaFM tool is uncertainty quantification enabling tool. This has minimum functionality but strongest uncertainty quantification capabilities. So what it really does is a user will provide their simulation model, whether it's written in OpenSys or Python, it doesn't, or any other VM software, it doesn't matter. You will import that in QuaFM, and then QuaFM will enable you to run different kind of uncertainty propagation analysis. And even more when you have experimental data that can accompany can match your simulation model, you can have that inside and then perform Bayesian calibration or deterministic calibration. So using this, you can also play with different workflows. For example, one common application we found was that you can first try to run sensitivity analysis using your model to identify what are the really important parameters among numerous parameters, and then perform Bayesian calibration. Using the same platform, you can perform Bayesian calibration to improve your knowledge in the parameter values. And there still will be remaining uncertainties. So you want to quantify what are the remaining amount of uncertainties or how much uncertainty was reduced by introducing Bayesian calibration. So all of these things can be done through QuaFM, and also other use case can be, you can first create surrogate model and then use them to run, generate like 1,000 or several 100,000 of simulation on samples with smaller computational effort. And the second level tool, first tool is EUQ for earthquake engineering, modeling, and simulation. Here we can see that we have some hazard load generators pre-implemented and also structure model generators pre-implemented. So for the hazard load, we have linked with our tool with peer-NGA database. So you can specify, for example, response spectrum curve, and then we will get corresponding ground motions for you. And also we support stochastic motions and site response analysis. And for the structural model, also we have some very simplified moment frame model, but also user can import detailed FA models. And similar thing for VUQ. Here recently we are really focusing on digital wind tunnel to make the CFD simulation much easier. We are developing some user interfaces to let the user run CFD simulations much easier. And then similar thing for Hydro UQ to simulate storm surge or tsunami, we are relying on CFD simulations. Here, and I also want to mention that we link with the wind tunnel experimental database as well. That can be used as the input of structural model. And then third level tool was performance-based engineering. We have same hazard and structure modeling tools, but we also have different options for damage and loss assessment with different fidelities for different building types and different hazard types. Here we rely on the backend called Pelican. So this is a Python package, so you can also take this package to other, say, Python script and then use them independent from the user interface if that's easier. And then very recently, we additionally incorporated recovery modeling module in collaboration with AROP, but also we are planning to have more recovery modules supported in our tools so that you can choose or compare and use it for your research. And our final tool is regional R2D tool for regional simulations. here we see that now we support multiple hazard and multiple asset definition inside one tool. This tool will be more discussed in detail by Dr. Jinyan Zhao in the second part of presentation, so I will not cover this to detail, but I do want to mention that there is a challenge in collecting data set when we try to run the regional analysis. So there are some strategies we take, and we also plan to have, we are developing the inventory generator module that can be incorporated in the R2D tool following this kind of workflow. So when we try to assemble the data set, we start from some basic footprint or parcel geometry data, such as OpenStreetMaps or Microsoft Footprint database. And then we augment third-party data. We found the text assessor data is a very good source of data. And so we harvest some information from the web. And then even if we try to collect all of the informations, we cannot collect everything that we need. So we additionally incorporate computational vision technologies using street view imagery and satellite imagery. So we also have a tool or Python package that is used to get those informations, especially needed for hurricane kind of analysis. So and use that to create our inventory data. And then still with this, we will have missing data. So for example, that can be coming from the trees that blocking computer vision estimation or human mistakes on any of other data set, or it can be just missing data. So for this, we use a statistical inference based on correlation in geospatial distance or feature space distance. So so this is just the workflow, how we generate the come up with the inventory data set that's used for the regional scale analysis. So with that, I'd like to change the focus to more specific topic. My focus will be how surrogate model works in EUQ tool. And then Jinyan will talk about R2D tool in more detail. So as you can see, this is just part of the functionality that is supported in SimCenter. So I would recommend you to check our website if you have other interest or other things that interest you. So now I will move on to surrogate modeling for seismic risk assessment. So the motivation was clear when following our workflow. One more thing that we are really emphasizing is the high resolution regional seismic risk assessment. And their workflow usually follows like this. When we put in some inventory data in terms of data table, there is a module that generates a structure, external linear structure based on the description. And also for the earthquake part, if we have the site of region of interest, then based on seismic hazard modeling, hazard models, we can come up with some ground motion time histories at each of their locations. Then what we do is to run nonlinear dynamic analysis and send the results to the fragility functions and recovery modules. And then the problem or the bottleneck we found out was that the nonlinear dynamic analysis was taking a long time to simulate. So we needed to come up with some way to make this faster, like a pre-trained surrogate model or a reduced order model. And this presentation is more focusing on the surrogate modeling. This is very brief, like idea of what is surrogate modeling. So when you have a structure that takes a long time to simulate, and if you need to run this multiple times, you don't want to naively run this every the finite element method every time. So instead, what you want to do is to run simulation only a few times, collect the data set in input and output space, like that will look like this, and then create some kind of regression model so that when you need to predict at a new different parameter combination or different input values, you can simply find the interpolation point rather than trying to run the original simulation model. So this kind of regression model are coming up with this kind of regression model is goal of surrogate, and there are different methods that can achieve this, but we are focusing on Gaussian process model for different reasons, but mostly because it really helps us to handle uncertainty in an intuitive and easy way. So, but surrogate modeling in seismic risk assessment is a bit more challenging because of the high aleatory uncertainty in the ground motion model, ground motion time history. So what does this mean is that this will be our structural system typically. So we have ground motion time history as input and structural parameters as input, and our response will be some peak response according to performance-based earthquake engineering. And if we create surrogate in this setting, it will more or less look like this. So we have in one axis have ground motion time history parameters and structural parameters, and output will be peak response. But this ground motion time history can be high dimension, depending on how you discretize, it can have like 1,000 dimensions. So having that, we're trying to surrogate the, those things will require like numerous data set to good estimation. So what we can do instead is to run to select ground motion features as input of surrogate instead of the full ground motion time history. So utilizing our engineering insights, those can be intensity measures of the ground motion time history. And then our surrogate will have much lower dimension, and it makes it easier to fit the surrogate model. However, there are additional challenges because of this, because even when we have the exact same ground motion features, our response can be quite different, because if there can be different time histories that shares the very similar ground motion feature values. But when we propagate this time history to structure, then we will have different peak response. So that creates the uncertainty in our prediction. So what we really need to care in surrogating seismic response is to capture this uncertainty accurately. And also because this uncertainty is what is really important in the earthquake engineering practice. So there are different strategies to achieve this. For example, some rely on so-called replications. That means we generate not only one samples, but multiple samples in each parameter locations. And also there are other ways where you first try to estimate the mean, and then you can estimate the variance even if you have only one sample. So those different methods are of course validated through the paper, and then we import this into the our tools. So that's what is going on when you select when you try to run surrogate using our EUQ tool. So this is the summary of problem definition. We use excitation parameters and structural parameters as input of our surrogate. And then because of the uncertainty that's not captured by intensity measure variables, now our output response is uncertain. So our Gaussian process model will try to capture this variance in an accurate way. So how does this work in EUQ is that you can easily select structure model, import your structure model, or generate structure model through our user interface. And then you can select the region of interest and give some excitation conditions. Then you can create surrogate model and export it into a separate file. And later you can also import this to run different kind of analysis that's resource intensive. So before going into demo, I'm just briefly showing the options that we are gonna select. So this is the workflow, again, modularized. So in uncertainty, so basically we will create workflow that looks like this. So in the first part, we will select surrogate modeling, and among those, we have a couple of surrogate models supported. The other one is probabilistic learning on manifold, but in this example, we stick to Gaussian process model, and also we will allow heteroscedastic variance because that the variance may depend on the parameter location. And then we will not use replication. So we can set those kind of options. And then in the event generation part, we will use peer NGA database to train the surrogate. But when we select the ground motion, we want to have special selection criteria. That is to make sure our ground motion covers the intensity measure space thoroughly. So say when we select 100 ground motions, these yellow points represent ground motion times, a single ground motion time history that's described as spectral acceleration, SA ratio, and the significant duration. So we want this 100 ground motion, which is yellow dots in these plots, to cover in the entire area of interest as much as possible. So there is a module that does that for us. So we select this uniformly distributed module. And then for structural modeling, we will just generate an MDOF column using EUQ tool. And then train the surrogate. And then later, when you import the surrogate, we use the exact same workflow, but we change the modules. So we want to run forward propagation using surrogate. And then we again want to select ground motions from peer NGA database, but now according to a response target spectrum. And then we want to choose surrogate model instead of dynamic simulation model to predict the response. And then it will predict the standard earthquake engineering demand parameters, which are trained previously. So surrogate model, of course, can predict only those that are trained previously. So saying that, I just wanted to briefly show you our user interface. So when you download the tool, the tool basically looks more or less like this. And here you can see that these vertical options represents different options, different puzzle pieces that I showed before. So we can walk through one by one and then to complete the definition of workflow. First, how you do is first to select the surrogate modeling option, and then there is Gaussian process model and other probabilistic learning on manifold surrogate model. And you can set the number of samples here. And there are some advanced options that if you are familiar with Gaussian process model, then you can play with this. And here you see that we have a heteroscedastic option. And to process the time history, ground motion time history into the engineering intensity measures, we can specify it here by saying that we will use SA as input of surrogate, and also SA ratio as input of surrogate, and significant duration as input of surrogate. So there there are some parameters also you can modify, but we will stick to the original one. And then in the simulation tab, this is where we create a building model based on by quickly defining the parameters. So here we'll say our stiffness is the input of surrogate by replacing the number with some parameters. And then in the event tab, there is PR and GA records. So if you want to select based on response spectrum, you can do this, but we want to have uniform intensity measures. And you can also specify the domain by selecting these options. And here I like to be careful with the number of ground motions because PRNGA limits the number of ground motions that can be downloaded. So should not try too many at the first time. And also once you download the data, you can also reuse those from reuse those in our SimCenter tool. So it will be nice to save every ground motion you download. And after specifying this, you can select ground motions. It will ask you to log into peer database. And then it will retrieve the data that are based on your selection criteria. So this shows you the summary of data, ground motions you get. As you can see, it's more or less uniform. So the yellow points represent the selected ground motion and blue points are just the grid points. So you can see the yellow points are more or less uniform across the domain, but the red point here tells you that when you're the ground motion with high duration and high spectral acceleration values are very rare, so it was not able to get it very well. So if you want to apply your surrogate in such these situations, you need to be careful. You need to be aware of the fact that it is extrapolating, so the accuracy might not be reliable. So it's just to inform the users on such informations. And then for the FEM part, we use OpenSys. This is linked with this simulation model. And for engineering demand parameter, we will just add standard earthquake one, which is interstory drift, spectral, the peak drift acceleration or roof drift ratio. And in the RV tab, we set the domain of parameters. When we train surrogate, we just use uniform, so the PDF is not as interesting, but it can be useful when you choose other distribution. So after specifying that, you need to run the button, click the run button, and it will run the analysis. I will not run this analysis because it takes some time, but I have the analysis ready that I ran this this morning. So once the analysis is done, this is the display that you will see. It shows you like what was the analysis time and how good is the is your surrogate training. So this is through goodness of fit measure, which is basically interquartile ratio, meaning within 50% prediction interval, how much of your data set lies inside the 50% prediction interval. So if it's around 50%, we say the model is okay, but if it's very off from 50, then we say the model is not well constructed, so you might want to revisit your surrogate model. And here the error is, all the errors are calculated based on live and out cross-validation prediction. So this one also compares the observation, the data set we provide versus the live and out cross-validation prediction. And we can really visually see how much of this sample lies inside like the 50% prediction interval and how linear it is in this space. So after this analysis is done, you can save the model using Save GP Model button. And then you are ready to run the prediction. So to do that, we come back to the EUQ tab. here we run four propagation as we discussed. We will run only 16. And then in the simulation model, we want to use surrogate model instead of physical simulation model. Let's import the surrogate model we just saved. And here it asks you to whether you will just want to predict the mean, produce the mean as output, or you want to resample from your final distribution of mean and variance. And we will stick to the later option. And for the event, now we want to still use PRNGA, but with some uniform hazard spectrum curve. And here you can specify longitude and latitude, and within our the internal library of PIR will take care of the spectrum curve shape. So we can select records. Oh, I forgot to include scaling. So here we can include scaling, some kind of scaling method, either minimize the mean square error, or you can anchor on one of the period value. And then you will see that this now mean of our response spectrum curve matches that of the target spectrum curve. And for the FEM part, we don't need FEM because we have surrogate. And for EDP, we already have, we will get, it's already populated with those that are trained. Here PFA is peak floor acceleration, 0 means 0 floor, 1 and 2 means 2 horizontal directions. And then we can set these different distributions for the variables. We can do any distribution, but let's just pick something that looks complicated. And if you are not sure with the parameter values, you can also specify distribution using mean and standard deviation. Here I want to make sure it covers the possible sample values are well covered by the training range. The training range was from 50 to 150, so this should be safe. And then I can make it run the analysis. So while this is running, I will show you, I will finalize my presentation. So this is more or less what will look like from the training output of this surrogate. So here we are also comparing what are the predicted mean from the surrogate versus what we can get from the nonlinear dynamic analysis, and also same for the standard deviation. The x-axis is just different quantities of interest, say peak interstory drift, that flow around direction one, kind of things. So this is just part of verifying that the algorithm works as intended. And then our next plan is to allow user to train surrogate using EUQ, and then this can be imported in R2D so that the regional simulation can be performed using this trained surrogate model. And this is planned to be released in end of December. So please check it out after that if you're interested in this. And then there are other interesting projects going on. For example, we are also testing out reduced order modeling to reduce the time for regional scale simulations while relying on more physics-based intuitions. And also we are have some working group to come up with surrogate modeling approach for the hazard event, especially something for the wind simulation results or the water part of fluid dynamic analysis results. So and to finalize the demo, this is the result we get from the surrogate models. We see that these are quantities of interest. The first few rows are the input values, and the last columns are the quantities of output values. And here you can also see the scatter plots between different input versus output values, and also for the so this one projects the data set into one of the input parameters and output variables. And we are also showing the prediction, like the distribution that's from the surrogate model. So surrogate model predicts that the mean will be around this point, and variance will be around amount of variance will be like this, and the blue ones are sampled from those distribution as we specified in this tab. So with that, I think I'd like to conclude my part of presentation. Thank you so much for listening.
Thank you very much, Sangri. Thank you. Maybe is there any questions at this stage, either through the various steps of the demo presentation or through the theory behind what we have seen on surrogate models and how to develop them? If anybody wants to ask a questions, please feel free to just either raise your hand or unmute yourself. There is a question about how this simulation platform can support improvement readiness to natural disaster in poor and low-income countries, from Shmuel Yerushalmi. Maybe you can answer, Sangri. In other words, what is the level of and quality of data that you need in order to apply these resources?
I see. So I do see some challenges in directly applying this to less developed countries, especially when they don't have hazard simulation model and also good inventory database they support. But I believe the inventory generation tools so they're applying to
Thank you very much. Yes, please go ahead. Please go ahead.
Yes.
There is a bit of lag because we are a bit far, but yes.
Yes. So applying those those tools to those kind of situations will require, I believe it will require additional technologies to find a way to collect the data set in different ways. For example, I know a research that uses drone-based technologies to quickly collect the data in the region that the database is not available. So I believe so we will need some innovative methods to incorporate those situations.
But maybe you can give an idea of what are the minimum requirements. So, would this work equally well if instead of having an asset distribution from real assets, you just have single degrees of freedom, randomly generated structures, for instance.
Yes, that can certainly be accommodated in our workflow, so we can get the user provided dynamic simulation model basically for each structure. And even so, then the question will be could be the quality of the results, but also statistically, if we are interested in maybe lower resolution simulation results, even randomly generated structural properties, but according to the statistics of the but generated to make sure that the statistics, aggregated statistics are matched, will give useful information for the policy decision makers, I believe.
Thank you very much, Sangri. And I don't know if there is any other questions from the audience.
Can I ask, you mentioned that
This
there
one.
is, can you hear me? Yeah.
Yes.
You mentioned there is capability of multi-hazard assessment on the same platform. So I wonder how the other, like for example, flood hazard, does it go through similar process, or what would be different when you do another hazard, for example?
I think that part of them will be covered in the second part of
Okay.
presentation.
Okay.
Is it right? Yes.
Okay, thank you.
Thanks for asking.
All right. Any other questions? I have a more general questions on the quality on how you validate surrogate models, but maybe we can take this towards the end. So thank you very much again, Sangri, and please, Jinyan, the mic is to you.
Thank you so much. Let me share my screen. Am I showing the correct view? Is this the presenter or the audience view?
Yes, it's the correct screen.
Oh,
Thank
the
you.
correct view. Thank you so much. So hello,
Now
everyone.
it's not.
No,
No, it's not.
Now it's not.
Let me swap it again.
Yes.
I hope it's correct now.
Yes.
But
Yes.
yeah, thanks.
Yes. This is fine now. Thank you, Jinyan.
Sure, thanks. So I'm Jinyan Zhao. I'm a postdoc scholar at SimCenter. I joined SimCenter about 5-6 months ago. And at SimCenter, I am one of the main developer of this regional resilience determination tool, R2D. And in this presentation, I will give you an introduction of how to use this tool to do natural hazard resilience assessment. And before I start, I want to acknowledge these researchers. They are all currently working or they worked with SimCenter before, and they all did substantial contribution to the development of R2D. And this sentence is how you could reference R2D if you'd like to use it to do some sort of research work. And I also want to remind you where R2D sit in the SimCenter software package. Sangri said we have a general uncertainty quantification application called QualFam. And for several hazard modeling part, we have the hazard specific applications. We also have a software called performance-based engineering, which gives us the physical damage and the social economic loss of each asset after some hazard happens. And above that, we sort of put everything together and do an analysis on a regional scale. And you can think of that as a repeat evaluation of the performance-based engineering for all the assets in the region. But of course, we do some system level analysis also in the end. I will talk about the details later. And regional resilience determination tool R2D is a multi-asset and multi-hazard software. By multi-asset, I mean we currently support the analysis, the assessment of building stocks. And in a release we are going to make in the next couple of weeks, we are going to support the analysis of transportation infrastructure and underground water pipeline infrastructure. And by multi-hazard, we currently support the analysis of earthquake hazard and also hurricane hazard. And we also support the analysis of some secondary disaster. We can analyze the impact of liquefaction in earthquake and also flooding in the hurricane event. So one typical application scenario of R2D is, say, I have the building stock in the downtown San Francisco area, and I also have a hypothesis earthquake scenario. I wonder how much this earthquake can cause, how much damage this earthquake can cause to this San Francisco area. So I can put both the building inventory data and the hazard data in R2D. And in R2D, we have the built-in very simple intensity measure-based building level fragility curves. So given the peak ground acceleration applied on one building, I can estimate the probability of several damage states. And with R2D, I can calculate the most likely damage states for all the buildings in the region. And I can also estimate the repairing cost of each building and the total repairing cost in the region. I think this is a pretty cool function. And if you want to do that all by yourself, you want to do each step by yourself, that requires a lot of work. But with R2D, we really simplify this process, and you can do this by clicking just a few buttons. And I think that also answers part of the question by the audience, how the research framework by SimCenter can help with the hazard readiness in low-income countries. Perhaps it's very difficult for those researchers, from those regions to do the steps one by one by themselves. But with R2D, we really automate this workflow, make the hazard assessment easier. So in the rest of the presentation, I will give you an overview of the user interface with a focus on the earthquake impact assessment, just like the example I just showed you. And after that, I will give you a brief introduction of how to do hurricane impact assessment. And I also want to introduce a few useful tools building R2D that can make your regional resilience assessment easier. And in the end, I want to mention several ongoing development. And if your research aligns with our development plan, perhaps we can collaborate. We are very happy to work together with you. And the last slides will be how you can install R2D and some resources you can find online. So if you open the R2D desktop software, you will see a window like this. At the top, there is a menu bar, and here is the main panel. And to the left-hand side, you can see the panel selection ribbon. When you click on each of the panels, this main window will change. I will show you what does each panel do later. But here you can find the run buttons. If you click this button, you will run the analysis on your local computer. And if you click this run at design safe, you can run the analysis on a high performance computer, which is provided by Design Safe. Design Safe is a project. Design Safe is a project sponsored by the National Science Foundation of the United States, but they offer free high-performance computer access to almost anybody in the world, as long as you register your account on their website. And with that account, you can log in your account in R2D and hit this button to submit your job to the Design Safe high-performance computers. And after your analysis is finished, R2D will let you know, And you can download your analysis result by clicking this button and do the post-processing of your analysis result on your local computer. And at the bottom of the window, you can see a program output dialog. You will see the analysis status output here. So in the menu bar, we have the normal functions like to open and save your analysis, to clear the input to the software. And you can find the links to our menu and some resources. But the two important part of the menu bar will be the tools menu and the examples menu. In the tools menu, you will be able to find the earthquake and hurricane scenario simulation tool and the BRIOS tool. Sanri mentioned BRIOS tool. The BRIOS tool is used to generate regional infrastructure inventory data. And the earthquake and hurricane scenario simulation tools are tools to help us create the hazard information, like to do some hazard analysis and figure out the ground motion field for a region if you are interested in earthquake hazard analysis. And I will talk about how to use these tools later in the later half of my presentation. But the examples are also very important. In the examples menu, you can find some built-in examples our team developed. And we developed the examples based on the most typical application scenarios in regional resilience assessment. And say if as a researcher, you are interested in hurricane assessment, you can open one of the example and make modification based on your preference, and you can do your customized resilience assessment for a region. So that's the menu bar. And if you look at the panel selection ribbon, they are ordered in a modular way. And this modular follows the order of the workflow in a regional assessment. The first two panels would be visualization of the input and output, and to define some general information, such as the units you want to use throughout the analysis and what type of asset you are analyzing. And then we have the panels to define the input hazard, to define the input of asset information, and to define a mapping from the hazard to individual asset. And I think this mapping is also called exposure models a lot of times. After that, we need to define how we want to model each asset and how we want to analyze the assets. And after that, we will need to define the damage loss methodology. Essentially, we are defining the performance-based engineering models here in this panel. And we also support uncertainty quantification in the structural analysis model. This uncertainty quantification part is very similar to what Sanri just introduced in earthquake engineering in the software EEUQ. We'll have a look at how they look later. And in the end, you can see the results in the result panel. So the first panel is the visualization. We essentially built in the software QGIS in our software. So if you are familiar with the software QGIS, this is just the same panel as you will see in QGIS. You can have a visualization panel here, and here is a list of the map layers you import to this visualization panel. And as I said, this is a generic GIS visualization tool. So you can import any GIS model in this panel. For example, here I opened the global active faults model, and the purple lines in this visualization panel are just the active faults that the global earthquake model foundation released. And if I right click on this map layer, I can also open the attribute table and do some research. So this is a very useful tool. The visualization panel is kind of a very useful tool to do some research on a spatial scale. And then the second panel in R2D will be general information, where you define the units, define what type of asset you want to analyze. Also, you can define what type of outputs you want to save after the analysis finish. Usually, we save the statistical summary of the engineering demand parameters, such as the peak floor acceleration. We also save the damage state of each asset and the decision variable, like what's the repairing cost and what's the number of casualty in each building. But if you do uncertainty quantification, you can also select to save the values in each sampling realization, and you can also save the intermediate result we use, which is asset information model. It is the equivalent to the building information model in a conventional way. We just have the geometry of each asset plus the structural analysis model of each asset all integrated in one file. And you can use that file to do some subsequent analysis if you like to, but you can save it here by checking this checkbox. And you can also save the intensity measure on each of your building by checking this box. So after defining the general information, we need to define the hazard to do our regional resilience assessment. For earthquake assessment, the most commonly used way to define the hazard is this user-specified ground motion option, where we will first define a set of grid points, which are shown as these blue dots. And then we will define what is the ground motion at each of the blue dots, at each of the grid points. To define the location of these grid points, we will need to load one CSV file, one spreadsheet file to R2D, and that CSV file contains a column called latitude, a column called longitude, defines the location of the grid points. Also, it has a field to define the name of a file containing all the ground motion record at that grid file. And here we need to load in the path of a folder containing all the files mentioned in this CSV file. And if in the subsequent analysis, you only need the intensity measure for your earthquake assessment, the files in this folder will be something like this. For each grid point, you have a list of realization of the intensity measure at that grid point. And if you would like to do time history analysis in the subsequent analysis, the files in this ground motion folder would be some time history record of ground motion. And some other options in the hazard definition is user-specified hurricane, which follows the similar format with earthquake ground motion, but you will need to define your hurricane-related intensity measure. We also support several other formats of defining the hazard. For example, the United States Geological Survey, the USGS, they publish historical earthquake scenarios with their specific format, and we allow users to load their formats to R2D. We also allow users to load a raster and GIS-defined hazard, and you can refer to our examples to see how they are implemented. In the end, there is a special option called regional site response. So that is meant to consider the effect of soil amplification in earthquake. Usually, the ground motion prediction models give us the ground motion wave at the bedrock level. But when the wave propagates to the surface and to the structure, the wave is amplified by the soil. So researchers at the University of Washington provided us a model to quantify this amplification effect. And we do that by defining the soil information at the set and defining the geological topography model, like what's the depth of the bedrock. And here we use OpenSeas to implement that soil propagation, that wave propagation model. But of course, we need to input the ground motion at the bedrock to get the ground motion at ground surface. And we need to define the units you use to input the ground motion. But with this way, you can calculate the ground motion the soil amplification effect on a regional scale. And I think this is a very useful tool for a lot of geotechnical earthquake engineers. So that is, so far I have covered how you can define hazard in R2D. And next we need to define the asset information to do our regional analysis. To define that, to the left-hand side, you can see the asset selection ribbon. So when you want to have multiple layers, multiple types of asset in your analysis, you need to go to each of this ribbon and load one asset asset inventory file to R2D. And for each of them, we support several ways of loading the asset information. The most common way is this loading the information with CSV files, which is a spreadsheet. In the spreadsheet, you need to define all the informations you need for your damage and loss analysis. For earthquake, and for the building level fragility analysis I mentioned at the beginning, you will need to define the structure type, either it's concrete or wood. You need to define the occupancy class and also number of stories, plan area to do the basic damage and loss analysis. For water and transportation, you need to load a similar information as well. And we also allow users to load their information using GIS format instead of this CSV format. There are just many options, very flexible options in R2D to load the asset information. And with the hazard and asset defined, we need to define the relationship to map the hazard on each individual asset. If in your hazard definition, you input the ground motion under each building in the region, then you can select this set specified hazard to asset mapping. But usually that means you are going to have thousands or tens of thousands ground motion files. That's not easy to maintain. That's a lot of computational cost. And also, very likely the ground motion under two buildings close to each other are almost the same. So you are just wasting some space and computational resources. So a more common way is to define the ground motion on a coarser grid field, like these black crosses. And then you can use this nearest neighbor algorithm to interpolate between the grid points to get the ground motion value in one of the building between the grid points. So this nearest neighbor algorithm is almost equivalent to a weighted interpolation between grid points, and you can find the details of the algorithm on our web page in our documentation. The next step in R2D is to define structural modeling and structural analysis. If I want to do a building level fragility-based analysis, we essentially have no structure model, or you can think the fragility curve is your structural model. But to put it easy, we just say we don't have any structural modeling here. We select this none option. But in R2D, if you would like to do some time history analysis for your building, you want a bit higher fidelity, you can select this built-in multi-degree freedom rule model. And we also allow users to input any of their OpenSea Spy script to generate any OpenSea structural analysis model. And we also allow users to just input a generic Python script. It does not have to be OpenSea Spy. It can be any Python script, and the users can define their structural analysis model in this.
Jinyao, we seem to have a problem with hearing you. Hello, Jinyao? Jinyan, can you hear me?
Let me go to his office and then.
Yes, because we cannot hear him.
Yeah, I also cannot hear. Let me check.
And he doesn't hear us clearly. Can you try to speak to see whether we can hear you? You don't appear to be muted on Zoom, so. We can still not hear you. Maybe you need to reset your audio. Maybe just use your computer audio.
You say so.
Oh,
Yes.
now we can hear you. Now
Yes.
we can hear you.
Thank you. I'm sorry for the.
It's all right. Just technical issue always happen. Don't worry. Please, you proceed.
Sure.
I think maybe we miss part of these slides. So.
Oh yeah. So I was just introducing how you would be able to use the multi-degree freedom rule model for your time history analysis. So the methodology of how to simplify a real building into a multi-degree freedom system is introduced in these two papers. But to implement that in R2D, we rely on the users to provide us a rule set to map this real building into several archetypes. And then we can do the nonlinear time history analysis using this multi-degree freedom model. You can refer to our example tool to see how to implement these rule sets. And because this is a huge simplification of the structure of the building, we allow users to input some standard deviation of the stiffness and the damping of this multi-degree freedom to account for their uncertainty. And the users also need to define the default story height of this multi-degree freedom system. And as I said in the previous slide, we also allow the users to input any OpenSea Spy script model. And in the OpenSea Spy is just an interpreter of OpenSea, and it is used for very general finite element analysis. So you can define your own finite element model with this option. But you also need to give us some basic information such as the dimension of your analysis and the number of degree of freedom in each node you define. Also, we need a mapping between your degree of freedom to which degree of freedom stands for the peak floor acceleration, which degree of freedom stands for the roof drift. We need that mapping to do our damage and loss analysis. And you can see our example 4 for how to implement this OpenSys script in R2D. So that was the structural modeling part, and based on different structural modeling, you need to select different structural analysis engine in the next panel. For the hazards, the building level fragility curve style analysis, we will select intensity measure as engineering demand parameter structure analysis, which means we use the intensity measure such as peak ground acceleration as the engineering demand parameter, and we map that to the damage and loss fragility curves that some design guidelines in the US give us to get the building damage probability. And if you use a multi-degree freedom Lu model for your structure modeling, you will need to use OpenSys to do structural analysis. And of course, if you select to use OpenSys Pi, you will need to use OpenSys Pi as your structural analysis engine. And the custom Pi function also allows you to use any Python script as your structural analysis model. Again, example 12 and example 4 shows that these two functions are meant for experienced programmers or more experienced users, but you can refer to these two examples to see how they are implemented in R2D. But these options are only available for buildings now. In our recent release, we are going to make for water and transportation infrastructure analysis, we only support intensity measure as engineering demand parameter style of analysis, but we do have plan to incorporate higher fidelity models for these two type of infrastructure. So after the building analysis, after the structure analysis, which gives us the structural response of each asset in the region, we can do the damage and loss based on the structural response. Here we use the Python package Pelican to do the damage and loss analysis. For different analysis fidelity, you need to specify different hazard and loss methodology. So if you have the standard earthquake engineering demand parameters, such as peak flow acceleration, you can select this hazards multi-hazard earthquake methodology. Well, if you want to use the fragilities based on intensity measures, you can select this, the second option. And for hurricane damage and loss analysis, we also have a suite of built-in fragility curves that you can do the building damage and loss analysis. And a lot of users, they are not happy with using the hazards fragility curves, which is provided by the US Federal Emergency Management Agency, FEMA. They want to use their own fragility curves for their infrastructure. We also allow users to do that, and you can refer to our example 9 to see how to do that. And here is an example of how to do the damage and loss for the simple example I showed at the beginning. Because the fragility curves are based on peak ground acceleration, we will select this intensity measure-based methodology. And this type of hazard damage loss methodology does not consider the effect of if the earthquake happens in the morning or it happens in the midnight. So we will select off for this event time option. But some damage and loss methodology can account this different. If an earthquake happened at midnight, perhaps there are higher casualty because people cannot escape from their building very quickly. So we allow this package Pelican allows users to simulate that effect. And Pelican is a probabilistic package, and it uses a sampling scheme to take account of the uncertainty in this damage and loss methodology. And the users will need to specify the number of realizations, the number of samples they want to use in Pelican. And here are just some checkbox to determine how you want to format your output. If you want to have a summary of the output, or if you want to have the damage and the loss result for each of the individual building, you can specify how you want to save them. And most importantly, in the end, if you want to study the damage and loss caused by ground failure, for example, the lateral spreading in liquefaction and the big settlement in liquefaction, you can check this box, and the Pelican can help you handle that damage and loss analysis. So in the end, the last two panels are uncertainty quantification. Sangri did a very good introduction to the functionality, like what is a surrogate model and how we can do the forward propagation. I will not repeat that, but I just want to say the random variables defined in R2D is only about the uncertainty in your structural analysis model. The uncertainty of the hazard model is automatically taken into account when you define the hazards. Say if you input a long list of the intensity measure realization, R2D will run all the realizations and give you the probabilistic distribution of the building damage, or the other type of infrastructure damage if you selected other infrastructure types. So after a long process, we are finally close to run analysis. Before that, you may want to quickly check where is a local job dictionary. That is where you can find the results after the analysis is finished. You can also set the path to some external packages we use, for example, OpenSys and Dakota, but usually these are set up already when you download R2D, when you install R2D, so you don't need to worry too much about that. And then if you hit the run button, in the program output dialog, R2D will tell you we are running some script in the backend, and this may take a while. And after maybe a couple of minutes, R2D will show you the workflow is completed and the results have been imported to the visualization. You can go to the visualization panel to see the, go to the result panel to see the analysis results. So in the results panel, you will see a visualization like this for each building. You can see what's the loss ratio after the event, after a hazard event. And if you click on one of the building, you can open the details of that asset to see what's the damage state of the individual asset. To the right-hand side, we also have a summary information, like what's the total casualty, what's the total economic loss. We also have some simple distribution to help you figure out how many buildings suffers very big damage, how many may suffer a minor damage, and also a table listing all the information from the analysis. And as I said, if you want to do some post-processing by yourself, you can find the detailed output in this folder, in this local job dictionary folder. In that, you will see a folder called template SimCenter, and then a folder called results. Inside results, you will see a folder called buildings, because I only analyzed building in my analysis. And if you also selected to analyze transportation infrastructure and water infrastructure, they will have their folders containing the analysis result for transportation and water. And inside buildings, each building in the region will have its own folder, and inside the folder you will see the analysis result. For example, the damage state, the decision variables and the engineering demand parameters. But that was when you run the analysis on your local computer. And as I said, you can always run the analysis on DesignSafe's high-performance computer. You just click on this button, log in your account, input your account info, and R2D will show you if you log in successfully or not. And then after you submit your job to DesignSafe, you can in R2D you will see the status of your job, because high-performance computer is shared by many people. Your job may very likely goes through a queuing process, and after a while, your job will run on the high-performance computer. And after it is finished, you can download the data from DesignSafe and do the visualization and post-processing as what you've done for local analysis. So it's a very long overview of the user interface. I hope I haven't bored you already. But that was focused on earthquake impact assessment. And if you are interested in hurricane impact assessment, there are just several minor changes you need to do. The first change is when you load the asset information, you need to include the hurricane assessment related information. Very likely you will need the first floor elevation, the flood zone of each building, the wind zone of each building, and the roof shape. Those are important features of a building that determines their behavior in a hurricane. And the second change you need to make in your assessment workflow is when you define the hazard, you need to define the hurricane-related intensity measures. For example, the peak wind speed and the peak inundation height. And in the end, if you select the hurricane-specific damage and loss assessment methodology, you would be able to do a regional assessment for hurricane hazard. So, so far, you should be able to do any regional resilience assessment for earthquake and hurricane in any part of the world, as far as you could provide us the hazard information and the inventory information. But as Sanri said, those information are sometimes quite challenging to get, and we in R2D we have these 3 built-in tools to help you get those information. To start with, you can find the earthquake scenario simulation tool in this tools menu, as I showed at the beginning. And if you click that, R2D will open the window look like this. And in this earthquake scenario simulation model, you can first define an earthquake rupture forecasting model. That means you can go to the fault models close to your construction site and interface some earthquake rupture forecasting model published by USGS or the global earthquake model to get what's the possible earthquake scenarios in the region and what's the mean annual rate of the earthquake rupture in that region. And we achieved that by interfacing to the USGS model and the GEM Foundation's OpenQuake engine to do the earthquake rupture forecasting. And we also allow some simple point source earthquake to do some quick illustration and education purpose earthquake rupture forecasting. After we forecast the earthquake scenario in this tool, in this earthquake scenario simulation tool, we allow users to select ground motion prediction equations and to define their intensity measure, define their spatial correlation model to get the ground motion field, to get the intensity measure field in the whole region. And the available ground motion prediction equation options are the equations developed by the peer next generation attenuation project, the 4 equations there. And the spatial correlation models are essentially the spatial correlation models developed by Professor Jack Baker at Stanford University. But so far we got the field of intensity measure in the interested region. And we can, similar to EEUQ, we can also go to peers database to select ground motion record that match this intensity measure field. And in the end, this earthquake scenario simulation tool will give you a file in this format, and that format is ready for you to input that to the hazard definition panel. So this tool is, I think this tool is very useful for defining the hazard, the earthquake hazard on a regional scale. And similarly, to define the hurricane hazard on a regional scale, we allow user to define the track of their hurricane and to define the parameters of the landfall. And using the models proposed in these two papers, we can calculate a field of the hurricane intensity measures, such as the peak wind speed in the region. And if some researchers, they want to study the effect of a historical hurricane, we also have a built-in database. The users can select one hurricane scenario in the database, define their landfall parameters again, and to generate a historical hurricane hazard and do their analysis later. So that's for defining hazard information. To facilitate the development of building inventory data, we have the BRIOS tool for buildings. As I said before, the roof type is a very important feature, a very important information you need to do hurricane damage and loss analysis, but it is usually missing from the open source database such as OpenStreetMaps database and the tax assessors database. So BRIOS can be a very helpful resources to get this type of information in your building inventory data. And BRIOS also support occupancy classifier, sub-story classifier, and the number of floors detector to augment your building inventory data. And to use BRIOS is rather simple. You just define the region of interest and define where you want to save the information. But BRIOS is a very big pre-trained model, and it also downloads a lot of images from Google Satellite, Google Earth. So it can take quite some time to run. So be prepared if you want to run BRIOS on your computer. And besides building inventory, we also support inventory generation for transportation infrastructure. But so far, we only support the study in the United States because we interface to the US government's database, such as US Census Bureau and the US Federal Highway Administration's database to generate the infrastructure information we need to do that we needed for regional damage and loss analysis. So in the end, I want to mention several ongoing development we are working on now. To begin with, as I said, we are finishing up the physical damage assessment for transportation and water pipeline infrastructure analysis. And we use the fragility curves from hazards from the US Federal Emergency Management Agency to do the damage assessment for the transportation and water. And we are also working on study the traffic and water flow performance for the infrastructure network. And we have a special queue model for the traffic simulator and a rewet model for the water flow simulator. And we are also working on integrating a framework called Perry Code to do the post-disaster recovery. It is a time step code to simulate what's the recovery status after each time step after the disasters. And in the end, we are also looking for models to do some compounding hazard analysis, like what if there are multiple earthquakes happened sequentially, or there are landslide happens at the same time with earthquake. And if this aligns with your research interest, we are very happy to collaborate. Please let us know. And I think this is also a good opportunity or good resources for you to populate and publish your research, and a lot of users can use your research through this platform. So this is almost the last slide I have. If you would like to download our tool, you can go to our tool webpage. And if you would like to see our source code, both the front-end application and the back-end applications, you can find them on our GitHub page. And in our tool webpage, you can, as I said, you can find the link to download the app. You can find the link to our documentation. You can also find the link to join our user forum conversation. The user forum is where you can post questions, you can request features, and you can also report bugs. And this is a screenshot I took yesterday. It seems R2D is receiving the most number of posts in this forum. And I look forward to see your feedback and see your question on this platform. And thank you very much for your attention.
Thank you very
Happy to
much,
take any
Julian.
questions.
Thank you to both Sangri and Yi for this very interesting presentations. There are a few questions. So the first one is on the Pelican loss model, and how does RT2 quantifies the uncertainty of the Pelican loss model? This question is from Francisco Bertimbaldi.
Okay, that depends on what type of analysis fidelity you are using. Like if you are using the building level uncertainty, the building level fragility curves, the uncertainty may come from, for a given intensity measure, for a given PGA, for example, the fragility curves only gives you the probability of several damage state. And when you have multiple intensity measure analysis, you need to some sort of integration to get the overall damage probability of that building in this event. So Pelican use this sampling strategy to do the numerical integration. And there, when you do some component level damage and loss, there are more uncertainties. For example, we know the building archetype, and if a fragility curve defines what's the damage of one column, but we don't know how many type of this column in my archetype. We only know a rough range of how many columns possibly in my building. So Pelican also take account of such kind of uncertainty, use a sampling strategy. And there is also one uncertainty we can deal with Pelican. So, and it is optional. So if the input engineering demand parameter is only a very small number of realizations, Pelican can fit an empirical distribution based on the small number of engineering demand parameter input, and then sample from that to get a more robust estimation of the damage and loss analysis results. So there are quite several mechanisms to deal with uncertainty, and you are welcome to look more into Pelican's documentation and also the performance-based engineering software's documentation to see more details. I hope that answers the question. Sanri, do you have anything you want to add?
No, yeah, I think it answered the question.
China, I think you are muted.
Again, there was a problem with my internet. It actually crashed. But anyway, I think there was one other questions, whether whether seismic resilience can be measured using these tools. I don't know if Sangri or Jinyan want to answer.
If you by this tool, if you meant R2D, yes, that is almost the one of the most important feature of R2D to measure the seismic resilience. But of course, so far we only have the damage and loss analysis right after the disaster. We are working on incorporating the recovery simulation in our workflow. And after that, I think we would have a more complete resilience assessment framework to not only know how much impact a disaster can cause, but also know how long it takes for us to recover from the disaster. Yeah.
Thank you, Jinyan. And this question was from Zizhan. I don't know if Zizhan would like to comment further on this, if you are online.
Thank you very much, sir. In a continuation, can we further develop this the tool for measuring the EL, the economic annual losses?
Excuse me, I didn't get the question too clearly.
Can you say it again, Zishan? I think it's about whether you also include economic losses. Is that correct?
Yes, economic annual losses, EAL.
Oh, I see. So the economic loss is included in Pelican. The Pelican fragility curves I showed you was based on intestine measure. I have the damage state, but Pelican also have such information for what's the replacement cost given the damage state of the building. So by conditioning on the damage state you calculated from all the analysis, Pelican will give you how much money you need to spend to repair your building stock. And also Pelican can suggest perhaps the building is collapsed completely. There's no chance to repair it. You can only replace the building. So yes, also Pelican also have information to do social factor assessment, like it can suggest how many casualty one earthquake event may cost. So for each damage state of the building, there is census data, or I'm not sure where the data from, but HAZAS, the Federal Emergency Administration Agency, they provide their data for how many people may get hurt given the damage state of the building. And that information is also incorporated into Pelican. So a short answer is, yeah, thank you.
So I just wonder whether if the data is different from the ASOS standards, how this would work.
I am afraid the data is developed for the United States, and for other part of the world, the users can use their user-specified fragility curves. We do provide the option to do that. There may be just some extra work, and if somebody are interested in that, we can help with them to develop their fragility curves.
And there are no other questions in the chat. I have a question that has to do with the way in which I think in the example that you showed, there was you used OpenSys to run a relatively simplified model of let's say a stick model or a 2D model. I wasn't, if you already have your fragility functions, I'm not entirely sure why you are also running full structural analysis, and whether this was nonlinear dynamics or was in some other type of structural analysis for earthquake output.
Yeah. Thanks for the question. So the fragility curves and the OpenSys model are somehow two different options. The users are expected to select from one of them. So it all depends on what level of fidelity the user like to do their regional assessment.
Yes, but so at regional assessment, what would be the computer burden of running because clearly you will need to run several OpenSys analysis. And will this be done in a pushover analysis type, or a SPO to IDA, or a full nonlinear dynamic analysis? So what type of analysis do you recommend?
I can give you a sense of how much time it may take for the fragility curve style of analysis. And for the example I showed at the beginning, the San Francisco example, there were 7,000 buildings in the analysis. And for hazard style, fragility curve style analysis, it took 30 minutes or so to run the whole region. And when we do the multi-degree freedom OpenSys model, it took I think it took 5 hours or so on a local computer. But of course, we allow users to run things on design safe on high performance computers, and the computation time can reduce dramatically.
That sounds very interesting. Thank you. Thank you very much for the very clear answer. Any other questions from the audience? If there are no other questions, then I have one more question from Sangri, as I mentioned earlier about the models that you will use in. So if you can run the OpenSys models, or albeit simplified, why would you want to run surrogate models? And what is the advantage of having the surrogate models in this respect? And what are the uncertainty associated with either of the approaches?
So we envision 2 use cases of surrogate model in the regional analysis. So first one will be when user have a very detailed FEM analysis for specific type of buildings. For example, this can be building model for school structure or hospital structure in the area, because there they might want to have higher resolution for certain buildings or even bridges. So in that case, we want to avoid delaying whole regional computations by focusing on those high fidelity simulations. So we might want to pre-train the surrogate for those archetypes of structures and use surrogate for only those cases. So in that case, that's the first case we envision. And the second case will be where we have a pre-trained surrogate model pre-implemented in R2D, which gets the same input as, say, Jesus style fragility curve, and probably will give a very similar output as the Jesus fragility function, but it can additionally account for some of the spatial correlations or correlation between different like subcomponents inside the structure that Jesus fragility might miss. And also, so even though their input and output are kind of similar, the response are estimated in very different philosophy, I feel like. So researcher has preference on like how Jesus is defined their fragility function or how non-linear structure model is identified. I'll say there's no perfect solution, so it more depends on like preference of the researchers.
Thank you very much, very clear again. Other questions? Again, none from the answer, so I have one more questions. On basically, how do you see the use of your platform in practice beyond the confines of the US for practical purposes? So if somebody, not for research purposes, but for actual, assessment of a region, if a government has interest in studying a particular region from the side, or a particular city or neighbor from that point of view.
I feel like having it can definitely help for the policy decisions, like when one need to so before Xinjian, would you like to start first?
I have some thoughts by using by practitioners. I am afraid these regional scale tools I presented, I think there are not actually so many practitioners are going to use that. Our users are some regional municipal managers, such as the East Bay municipal manager. They are interested of using our tool to do some regional assessment for their water pipeline system. Also, the California Transportation Management, they are interested of such a regional tool to organize their traffic flow network. So I believe there are also such kind of stakeholders in the part of the world beyond the US, and our tools can help with their work. And for the individual asset level analysis, as far as I know, there are quite some design firms in the US, like the structural design firms. They are using the performance-based engineering tool to quantify their design. Like they have a building design, and what if the earthquake happens, how much money they need to invest on repairing the building. So I think there are quite some applications by practitioners beyond academic researchers and beyond the US. Yeah, but I think there may be still a way to go to extend our tool to other part of the world. As you said, the data we have are essentially developed for the US, and whether it can be extended to other part of the world, I think there are some research need to be done.
Thank you very much, Jinian. Yes, and of course, it would be more a matter of understanding whether people with data from other parts of the world can actually use your framework with their own data. And that, I'm sure, is a conversation that you will be having on your GitHub and the repository, and in the next days and weekend, I exhort all our audience to continue to remain in contact with you and have those conversations with you in relation to the usability of SimCenter to a wider audience, which is the purpose of these webinars, among other things. Also it's quite interesting you refer to practices that might look at individual assets and what are the future of these individual assets and their likelihood of failure or damage and how they recover, because this indeed will be the conversation that we will have in January with Thornton Tomasetti, which are based in San Francisco, indeed. So with these notes, I would like to ask everybody to thank Jinian and Sangri for their excellent presentations and for having, so clearly elicited the characteristics and use of the SimCenter computational apps. And we will continue this conversation offline on all the usual channels, and you will be able to see the recording of the presentation on our Epicenter YouTube. Thank you again, Sangri and Jinian, and thank you everybody for listening and participating. Thanks a lot.
Thank you so much. Thank you,
Thank
everyone.
Thank you, Jinian.
Hi, and thank you. It was a very nice presentation.
Thank you for attending.